My screen is visible.
Yes, ma'am.
Yes, ma'am.
So yesterday, what we did is we have parameterized the dimension, correct? So we have parameterized the dimension of core as well as dimension of winding. Does anyone have doubt in that? No
Ma'am,
doubts?
No,
actually, someone getting the trouble, ma'am, where the variables we like selected, no, ma'am.
Yeah.
So when they are going to property section and the changing the variables dimensions, they are getting trouble, ma'am.
So what trouble they're getting? Can you explain
Uh,
in brief?
yes, ma'am, I will share the screen, ma'am, so that you can let know, ma'am.
Right. Now you want to share it through one thing. Okay,
Ma'am.
we'll solve that issue first then. Please share the screen. I've
Okay,
stopped
ma'am.
my screen sharing.
Okay, ma'am.
Are you sharing?
Yes, ma'am. Wait 1 minute, ma'am.
Fine.
Ma'am, are you able to see the video, ma'am?
I'm able to see the video, but parameters I'm not. It's not visible. That is small.
1 minute, ma'am.
Uh, just play the video in landscape now.
So can you see, ma'am, right now?
It's not visible. Yeah. No,
Ma'am, can
it's
I
not.
share this video? Can I share
Yeah.
this video in WhatsApp group, ma'am, so that you can see it directly?
Okay. Okay. So, should we sort that issue now or after this class of 25?
After this class is okay, ma'am.
So yesterday, someone was not being able to open the Ansys file. That issue got
Ma'am,
sorted because no one messaged me. So that issue got sorted.
Yes, ma'am,
yes,
that was
ma'am.
sorted, ma'am.
So, please, after every class, please save your geometry because most of the so most of the time we will be using the same geometry. So after every class, please save that file. Okay.
Okay, ma'am.
Yeah.
okay, ma'am.
I'll not tell you every time because
Ma'am, one
yes.
more doubt.
Yeah. Yeah.
Ma'am, by applying the boundaries to the geometry, uh,
Yes.
by boundary balloon boundary
Yes.
applying, ma'am,
Yes.
they
Yes.
showing error like boundary balloon one can only be assigned to 1D entities.
Then we might have done something wrong because it's not showing any error to me. I'll explain it today also, like in recap session and explain it again. So please check if you did in the same way. Okay.
Okay, ma'am.
Yeah. So we will start. Mm. So yesterday, parameterization is fine, right? The one Someone, those who are getting error, please, I think you can give the video to Vamshi. He will share it with me. Okay.
Okay, ma'am.
We will start with boundary. Why we need boundary? Can anyone answer that?
To
Okay.
reduce to reduce the time, ma'am. Ansys time,
More, yes, more than reduce,
simulation time.
more than reducing the simulation time, our answers should know that what is our area of interest, right? Like,
Yes,
uh, yes. So, till how much like area we want simulation to get run, right? But if we have just choose our geometry as our boundary, then outside this, if any flux flow means any flux linkage or anything is getting is taking place, that we will not be able to see. That's why we always apply boundary more than our geometry, right? So
yes.
for applying a boundary, the first thing is from here, it is by default an object. So please select edge here and select the four edges of this boundary.
Screen is not visible, ma'am.
Okay, sorry. Okay. So by default here object must be shown, right? So for applying boundary, just change that object to edge and uh, then just select the four edges of your boundary, your region. Okay. Select the four edges and then apply boundary. Right click and then assign boundary and then balloon. Try it in this way. If you're still getting error, then send the screenshot to me. I'll just see. Okay. Second thing is excitation. So after boundary, there comes excitation. So for this, we have assumed that our windings are interlinked. So the orange ones are secondary coils, secondary windings, and the green ones are the primary. Actually, yesterday I changed the name also for this. Please do that so that we will not get confused. Okay?
Hello, ma'am. Sorry to disturb, ma'am.
Yeah,
Ma'am, please record the video, ma'am.
it's recorded already.
Record. Oh, it's fine.
Let me just share this. Yeah, let me share that. So boundaries done for excitation. We have assumed that we are having interleaved means interleaved geometry. So first is this orange ones are our secondary windings and this green ones are our primary windings. So for assigning excitation to our primary windings, what we have done is we have selected all our primary windings, the green ones, change it to object. Okay. Just for boundary, we will need it to be on edge. So just select all the primary windings, then assign excitation and then current. Okay. For this, we have assumed that our primary current is 10 ampere. So we have put 10, right? Then type, there is solid and there is stranded. So we have selected solid here. In later part, you will select standard also. That time I'll tell you the difference. Okay. And then direction, how yesterday I told you how we have selected the reference direction, right? It is how the current is flowing through the coil. So if it is flowing in negative negative y direction, your reference direction will be negative. If it is flowing in positive y direction, your reference direction will be positive. So for primary coil, it is negative. For secondary, it's positive, right? So
Yes.
we were done with our excitation, 10 parameters. So I told you that don't worry about this yesterday. So today, why we made it, I'll tell you. Okay. Then mesh operation. Yesterday I told you why we need mesh, right? So what Ansys do is it does not consider the whole geometry. It divides that geometry into small segments and then solve for that segment. So if your segment is too big, you will not get optimized result. Uh, the results are not that good. But if your sections are too small, then your simulation time will increase. So if the sections are big, you will not get accurate results. And if your sections are too small, the simulation time will increase, right? That's why, mostly I follow this thumb rule that whatever is the dimension, I keep its 1/4 as mesh. Okay. So in this way, we have assigned mesh operation to a core and windings, right? Then in analysis part, at solution setup, here you you don't need to worry about anything else. Just go to solver and just select adaptive frequency. Just change adaptive frequency according to your design. So if you are designing it for 50 hertz, you can select 50 hertz. If you are designing it for high frequency, you can select high frequency. Yesterday, what we selected, high frequency, right? So we have kept it at 150 kilohertz, right? And here we are just increase the percentage error so that even with that error, we can get a good results. Okay, so percent error, 5% error is fine for us. It is 1, but we have just changed it to 5. Okay, in analysis, only this much part we did. Optometrics, for now, we don't need it. So I think we are good to go. We can simulate our geometry. Fine. So just validate it first. If you are getting warning in boundary, it's fine. If warning means we are not concerned about the warnings, but if you get some error in any of this, that means something is wrong here. So your simulation will not run. Okay. So we can see we can see that in boundary we are getting a warning, but rest all are fine. Okay. So just here from validate, you can check if all the parameters are fine. If it is fine, then you can click on analyze all. So in the bottom part, you can see your progress here. If it helps. Yeah. So this our simulation is done. If you get this message, that means our simulation is done. Okay. Should we start analyzing then? You guys understood? You guys
Yes,
understood?
ma'am.
Should we start with the analysis part?
Yes, ma'am.
Yeah. So let's start with the analysis part then. Just press Control A here so that your whole geometry will get selected. Then right click, then fields B, then magnitude of B, all objects. Here everything is selected. You just have to select all objects and done. You will see this type of field, okay? I've been able to see this. So this, what this is signifying is how your flux is flowing in the windings and codes. Right? So through this, you can check your flux linkage. And so now you don't want to see, you just want to see in the windings. Okay, so what you can do is close the plot visibility, then just select windings. Again, field E. Now, that is so now we can just select just can you see? Can you see? So what you will see that it is more on the surface than at the center part, right? The flux linkage is more at the surface than at the center of the winding. Can anyone tell me the reason for this? Okay, so for tomorrow, you have to search this. Okay. Fine. Your tomorrow's assignment is please first again find the properties of code, working properties of transformer code, working of transformer, then read about the losses and then see why we are getting flux linkage like this. Okay, fine. Yeah. So through this, you can see how much flux is getting linked between the two. Okay. Now you want to see the flux lines. Here you are just seeing the overall versions, right? Now you want to see that flux like fine flux lines. First, let's just see how the flux lines looks like. Then we can see how we can fine tune it. Okay. So I can just little visibility to the off. Then select all field, then A, and then flux lines. Can you see how the flux is flowing and getting linked?
Yes, ma'am.
Yeah. So now you want to just fine tune it, like you want fine lines, right? So what you will do is click on this color, click on the color palette that you are getting. Then in marker and in scale, sorry, change the number of divisions to 100 or more. You can change it to 50 or how much lines you want to see. It's up to you. Then apply. Can you see? Now you can see fine lines also, right? To understand this, how to change your flux lines, like how much you can set how much lines you want. If you like change it to 100, it will get more concentrated. Okay,
Yes, ma'am.
understood?
Yes, ma'am.
Yeah. So now you know how you can see the flux linkage, flux flow, is how the flux is flowing, how the flux is linking, right? Now you don't have to visualize it. You can see in FEA, like it is quite visible in FEA. Most of the times when any like when our professors teaches transformer, it's like we have to visualize that it is flowing through this, it might be getting linked like this. But here you can just see it, right? So this is also one of the like importance of FEA. If you want, you don't need to visualize everything. You can just see how the flux is getting, why it is coming. Like in future, I'll tell you some of the things like what is the importance in it, especially like in wireless power transfer. So you will understand that. Okay, because since our future objective is designing the coils for wireless power transfer also. So that time I'll make you understand what is the importance of this. Okay. So we are done with flux lines now. So now we will just close its visibility. So now we will see how we can, now we will uh, calculate the losses. So today uh, we will concentrate on copper loss, right? As per finding loss, right? Core loss we will cover in the next class. Fine. So just for losses, right click on the results. Here you will get solution data, and here you can see loss. So solid loss is 3.2. That is the winding loss. Okay. But now I don't want to see whole loss. I want to see individual losses. So what is the loss in my first primary winding, second primary winding, first secondary winding? That also we can do. So if we want to see individual losses also, that we can do. Why this calculation is important? For efficiency calculation, right? If we know our core and winding loss, then we can calculate our efficiency, right? So if we design a transformer for some frequency and for some like turns ratio, and we have selected some material for our cores and winding, so we can check what efficiency we can get, including the core and winding loss, means efficiency of what will be the efficiency of the transformer, so that you don't have to like before you make the hardware, you can just like cross check your design, or you can just validate your design through FEA. Understood? So now we have seen the uh, winding losses as like whole winding losses. Now, if we want to see individual winding losses, what we will do is go to results. Oh, sorry, go to field overlays, then calculator. quantity, select ohmic loss here. In geometry, now I want to see for primary coil 1. So at a time only one winding you can select. Okay. Primary one. Okay. Then integrate it and then evaluate. Here you can see loss for first primary wire, first primary layer, right? Similarly, in this way, we can calculate for individual winding also. For all of this individually, also we can calculate. Should I repeat it or you got it? Okay, I just repeat it again. So, for calculating individual winding loss, go to quantity, select ohmic loss here, then in geometry, I'll see for secondary. Okay. Then from scalars, select integration and evaluate. You can see for secondary. You got this? You got this? Does anyone have any doubt in? Are you guys doing it on your own geometry? Or you are doing this calculation in your own answers? Or you are just seeing this? Hello? Hello? Am I not audible? Should I repeat
Yes,
it
ma'am.
to you? Should I repeat it again? Or you understood? This is
Repeat it
just
once, ma'am.
okay. This is just the formula.
Yes, ma'am. Once again, can you repeat it?
Right. So this is the formula for loss, right? So this is our ohmic loss and we are integrating it so that we will get our winding loss. Fine. So just this formula we are using, but in Ansys. So what we are doing is, you understand how to get like total winding loss? Just go to results and solution data type. Here, just select loss. You will get total winding loss. But we don't want total winding loss. We want to see what is the loss in individual windings. So for that, what we will do is go to field overlay, right click on it, go to calculator, go to quantity. Here, select ohmic loss. For the geometry we want. Now I want for primary 11, 1, 1. Okay. So I'll select that geometry, then OK. Then in scalar, integrate it, and then just evaluate. So what we are doing this, we are just using that formula here. Okay. This is already been calculated. You are just using that formula and getting the individual winding losses. Now you understood? You can do this for every winding. Okay. There
Okay,
are
ma'am.
more options here. uh, you can just explore this. What if you want? I mean, if you want to calculate everything, anything, it is available here. So you can just explore it more so that you will get how this calculators work, like this, how this calculator option operates. Okay. For now, I have just told you how to calculate winding losses, but you can do much more in this. Okay. It has all types of options, mathematical options. Fine.
Yes, ma'am.
Yeah. So this by default is in words SI unit. Okay. So now we have seen this is our date for objectives, right? So we are done with our losses. Now we want to see the inductance, right? Inductance of your coil, right? So for this, for these we need parameters. So you have to select all the windings so that we can analyze it uh, for its inductance or mutual inductance. Okay. So for this, you need parameters. So uh, while doing your simulations, whatever excitations you have assigned in parameters, select all that windings. Okay. In any case, this is the transformer case, but in future also you will see that we will do it for all the cases, for whatever we simulate, whether we simulate inductor, whether we simulate normal planar coils, or uh, even like things like that. So we will see that we will use the same options. Okay. If you will not select this matrix, you will not be able to see the inductance and mutual inductance of the coil. Fine.
Yes, ma'am.
So let's start with inductance then. For calculating inductance, go to results, then solution data, and here we will see the inductances. Okay. But what you just want that uh, inductance, your self-inductance, that is like primary to primary inductance, then mutual, that is primary to secondary, and then your self-inductance of primary, self-inductance of secondary, and mutual inductance. Only these three quantities you want, right? But here individually it is given. So now what you can do is you can make uh, this as one unit, like all the primary coils as one unit and all the secondary coil as one unit. So how we can do that? Again, we have to go to parameters. So what we will do is right click on this parameters, right click on the matrix, sorry, and properties, and then post processing. So here, this post processing option is coming. Maybe in the future version, actually you get option as reduced matrix. So it is one and the same thing, but post processing and reduced matrix. Okay. So for this version, it is post processing, but for like 2020 or after that, we will get an option like reduced matrix, but they perform in the same way. Okay. So we will just group them. Group. You will not see this. I've already actually grouped this. I'm trying. I've already did this. So what I did is first I've selected all the primary coil and just group it here, and then I've selected all the secondary coils and group it here. Okay, fine. So we are getting one set of primary coil and other set of secondary coil. So now we just have primary and secondary coil. Okay, you can ungroup it from here. Okay, let me ungroup it and let me tell you. So just select all the primary windings and group it. Here you can name it as primary group 1, whatever you want. Okay. Then select all the secondary coils and understood how we group the coil. You understood? Am I going too fast today? Do you want me to repeat anything?
No, ma'am.
It's fine, right?
Yes, ma'am.
So then now we want inductances. So what we will do is go to results, right click, solution data type. So just click on R and L. So you will get resistance and inductance for that coil, and click on post process. So now your matrix has reduced to just 2 into 2, right? So this is self-inductance for primary, this is self-inductance for secondary, and this is mutual inductance. So here from here also you can change the unit and all if you want. Understood? This much you understood?
Yes, ma'am.
How to
Yes, ma'am.
analyze the field, how to calculate the losses, and how to get inductances. These three we covered in this class. So you guys understood everything? You want me to
Yes,
repeat?
ma'am.
Okay, fine. So one more option is if you don't want to go it in that way, here also you can do right click on the results, then create edit current report. So you can plot it also and get data table also. So I will tell you where we can use the plot option. So for now, we will just see in data table. Here, select L inductance and whatever inductance you want, look between primary, secondary. You will get the same results here also. Understood? So that is one of the way. This is the second way. Here you can also plot all the four if you want. Also, you can get all four if you want. So it will be like this. Right?
Yes, ma'am.
You can delete this if you want. It's fine if it takes more than. So now, uh, actually, validation of magnetic parameters and losses we have completed. Actually, I was going to start this today, but I'm not there, so we will not start this. What we will do is we will proceed with day 6 objectives. Okay. So this will take time because here we will first we have okay. So for tomorrow you have one more like activity to do. Uh you have this file. Do you
Yes,
have this file?
Yes, ma'am.
No, yes or no?
Yes, ma'am.
Yes. So if you have this file, please simulate this. Please draw this geometry for today so that we can just proceed with the analysis part, AC analysis. So for now, we are doing like eddy current analysis. Tomorrow, we will do transient analysis. But I want all of you to draw this geometry today, and then because I'll directly start with the analysis part. Will not again draw this geometry. Fine?
It's, ma'am, it's fine.
Okay. So we will start with then parametric study in 2D transformer model. I told you we need parameter for some for few calculations, right? Like that, not only convenience is not the only reason that we go for variables. This I've told you, right? I today I will tell you what is its importance, right? So so what we will do is we are given current as a fixed value, just change it to variable. So double click on your values and change 12 ampere to I1 and for secondary 8 ampere to I2. taking some time. Even you can keep the current also variable, and then you can analyze things. Not only dimensions, even current also you keep as variable. So anything, even the material also you can keep as variables. Okay. So first we will see with respect to current, and then we will see with respect to materials. So now what we have done is we have replaced our fixed current with some variable. I1 for primary coil and I2 for secondary coil. Initially, my current was 12 ampere for primary coil and 8 ampere for secondary coil, right? Now I want to see how my winding losses are getting affected if I change my current. Okay. So for that, you don't need to change your current every time and take results. What you can do is you can just like if you want to analyze for primary current, if you want to increase your current from 10 ampere to 20 ampere, for example, in steps, or like want to see if my current get increased from 10 to 20, what results are you getting? So you don't need to do it like first for 10 amperes, then for 15 amperes or 20 amperes. You can just directly uh, put it as variable, and then just directly can sweep it. I just like tell you how to do it. So for doing that, this optometrics option is there. So what optometrics do is just add it parametric. So you can add it here. So now I want to uh, change my current from uh, 10 ampere, for example, to like I want to analyze if my current is changing from 10 ampere to 15 or 20 amperes or to 30 amperes, how my losses are getting affected, right? So what you will do is just change, starting is what initial current you want. It can be less than the initial value, or it can be more than the initial value. So it is not like if you put initial value as 10 ampere or 12 ampere for I1, so you have to start with 12 ampere. That is not compulsory. Okay, you can start with any value you want. Fine. Let's just say we will start with 5 to 20. Step sizes, how much like steps you want for 5, between 5 to 20, on which level you want to check your losses. So after 5, it will go at 7. It will give you the result at 7. Then at 9 till 20. You understand this? What is step size? What is the start value and what is the stop value? Is it clear?
Yes.
Yes,
Should I
ma'am.
repeat it or it's fine? Okay, so for this, if you will, in sweep also there are two options. You can just keep like one variable, or you can add two variable. So if you will add two variable, it will calculate, or like example I'm telling you. So for I1, if I am increasing my current from 5 to 20 with a step size of 2, and for I2, I'm increasing it from 6 to some 12 value with a step size of 2. So it will calculate at every point of I1 and I2. Like for I1 at 6, it will calculate for keeping I2 as 6, it will calculate for all from 5 to 20. Then it will go for I2 8, it will calculate for all. So if you will keep two variable, both will get calculated. You understand what I'm trying to say? Here, see, in table, can you see? So it will calculate for 5, 7, 9, 11, 13, 15, 17, 19, and 20, right? So if you add I2 here, stop. I'm just taking random values, just to make you understand it's important. Can you see? It will calculate at every point. Now you understood what I meant when we use variable, it will calculate at every point. So now you understood. So for 5 ampere, it will calculate from 4 to 18. Again, for 7, it is calculating from 4 to 18. So this will keep on going. Understood? Then, if you want to sync it, what sync means is I want a like if I want my primary current to be 12 and I want my secondary current to be 8 only. Then I want my primary current to be, say, example, 12, uh, 14, sorry, 14, and I want my secondary current to be 6. So I want like fixed pairs. If I want fixed pairs, I don't want it to calculate at these things, right? So I don't want my secondary current, since all the sweep I don't want for this. I want pairs only. I want for 5 and 8 only, then 7 and 4 only. So that also you can do with this. So you can just sync here. You can just select both and sync it here. Then what it will do is from starting and stop point with a step size of 2, it will form pairs. But for that, for forming pairs, it should have same order, which we are not having. Same point means like same number of sweep points we need to have. Here we are not having that. That's why we are not being able to sync it. You understood? So if here are 10 points, here also it should be 10. Then only it can form pairs. You understood? Is it clear or it's confusing? Should I repeat it again? Is it confusing? Does anyone have any doubt? Or should we proceed?
Yes, ma'am, we can proceed, ma'am.
Yeah. I'll just change primary current. For now, I don't want. So my secondary current is fixed now. I'm just keeping this as variable, though both are variable, but I just please mute yourself. If you have questions, then only Yeah. So I want to keep my secondary current as 8 ampere only, and I just want to change my primary current. So only primary sweep I'm giving. Okay. You understand now how I have given this sweep? Then again validate and also. So now that eight there, because we have given eight steps as of there are 8 points. That's why we are done with the analysis. So it will take point one by one, and then it will calculate, means it will do the simulation for that point, and then it will take the other point. Here you can see that. Just wait a minute. Hello. Sorry.
Yes, ma'am.
Yeah. Yeah. So here it will take that points one by one and will evaluate at every point. Okay. You might get some warnings, but unless you don't get any error, it's fine. When we will hear that a rectangular plot will come in picture, then we have this parametric switch. Let's see if we can plot this for I1. Let's plot solid loss with respect to I1. Okay. Can you see this? So how the solid loss means our winding loss is changing with respect to the value of current you can see here. So understand the importance of this parametric switch, why we are parameterizing the things. You understood?
Yes, ma'am.
Yeah. So for just seeing the result, what you can see is go to results, right click it, create eddy current report. In rectangular plot, you can plot it. In data table, you can see the table, means in like values form it will come. So in primary sweep, just give the parameter that here by default frequency will be there, but you have to change it to the parameter that you are changing. So here we are changing I1, right? And we want to see how is losses getting affected because of it. So we will here multiple things are there, but because we want to see only losses, we will click on losses and that to solid loss only. We will click on solid loss and then new report. So now table will come. You understood? This is just an
Yes, ma'am.
example how we can use this parametric shift. You can just play with it and you can like if you want to switch even materials to see which material is good for you. So if you want to see, if you want to switch core materials and wanted to see how like varying core materials, how your core losses are varying, that also you can see. It is just I was telling you how with current your solid loss is getting increases, right? So now let's see how we can change the material. Fine. So by default, we have kept it as ferrite. We will just see how we can change the material, but because we have not analyzed core loss for now, the core loss analysis we will do tomorrow. Fine. For today,
Yes,
I'll
ma'am.
just tell you how we can uh, use different material for core. But today we will not analyze the core loss. Tomorrow we will use this function again and we'll see how different materials are affecting the core loss. Okay.
Okay,
So
ma'am.
for changing the material of core, you are getting these properties here, right? Just click on one of the variable, double click on one of the variable, sorry, this window will appear. Okay. What you will do is add your, so add array first, then name material array, because it's like array. Here you are giving material name, right? So first what you will do is add array, then material array, then here edit in grid. So add rows, number of rows. So you just want to see, you just want to change from ferrite to iron and then to uh, I'm just keeping the already available material here. Okay. If we will like add a new material, that also we can put. But for now, I'm just putting the already available material here. So what was the name of the 1006? Yes, whatever materials are available here, that only I'm keeping here. Okay. So first is it's small. Keep keep in double inverted commas. This is very important, or else it will not work. See here, for getting that warning also, please keep it in double inverted. Okay, this you will get. Then what you will do is add material index. So, like sweeping material is not that straightforward. Okay, you have to follow certain extra steps for doing it. The sweeping current and all is like easy dimensions and all. So if you want to change the dimension and see the effect, you can do that. But material sweeping is not that easy. You have to follow certain like some more additional steps here. Okay. And it's not that like straightforward thing. So after you have created your material array, right? So you want to switch between ferrite, iron, and steel, right? Now what I'll do is again I'll add property. Here you can name it anything. It's just like I have named it at material index. Then click on array index variable, and here associated variable is the variable which you have just now added. Okay, so it's material array. If you have more than the more variables, a list will come. You can select any one of that. But for now, we are just having material array. So by default, it is showing material array. Understood? Don't change anything here and just click OK. Material array from so first add an array with the name of the materials that you want. Then add a property where you means add extra variable which will get associated with that material array, and then just click OK. Now you can see that these results are not valid now. Okay, so now in ferrite here what you will write material array in square bracket material. Okay, you understood where we are writing it, where we have defined ferrite as where we want to change the material. So now because now we are concentrating on material of core, so that's why I'm changing material here to material array. Understood? So then just click on copy. Fine. Then in optimetrics, now I'll tell you what to do. We'll just delete this one. Add here material index. You know, our when we add the grid, it was starting from 0, 1, 2, right? So our start point was 0. Understood now what I'm saying? When I was writing my material at that time, we were forming the grid. Serial number wise, 0 was coming first, then second, then third, right? Do any of you remember that?
Yes.
Yeah. Okay. Let me show you. So get confused. Find out in 0. Yeah. So here, when I was writing my material, first serial wise 0 is coming, then second index, right? So 0, 1, material index was first is 0, then 1, and then 2, right?
Well,
Okay, so that's why in optics, we will add that material index variable and start it from 0, stop at stop at
2.
2, and step size will be 1.
1.
So 1, 2. These 3 materials only we want, right? So if we wanted 5 materials, it would have been 0 to 4 with the step size of 1. Okay. So it depends how you have formed the grid, how you have how much material you want to try. Okay. Then add. Okay. And again, you can follow the same process, validate it and analyze it. Just that. But now I'm not analyzing because I cannot show you the like how the core losses are varying with respect to material and all, because I have not taught you that for now. So tomorrow we will do that and we will see how by varying the material, how the core losses are varying, and how you can add your own material, how you can select your materials, right? And I think if we are done with this tomorrow, day after tomorrow, we will start with 3D transformer. Okay.
Okay,
So I
ma'am.
think by tomorrow we will be done with like day 6 work. I told you that some portion will take time. So this wireless power transfer, I'll not be able to complete it in 4 days. That's why I'm like rushing the transformer part so that whatever objectives I have decided for wireless power transfer also will able to complete that. Okay.
Okay, ma'am.
So are you guys like understanding it or like you are feeling that I'm rushing the things? Are you guys being able to understand?
Yes, ma'am.
So you can message or email me anytime you want. If you have any doubt, I'll solve that doubt. And the person who was getting actually today I leave the class early because I feel I'm not well. So today we'll get to early. Maybe I'll adjust this class on Saturday or Sunday, like half an hour. What we have missed today, I'll adjust it on Saturday or Sunday. It will be fine for you, right?
Yes, ma'am.
Yeah. So
Yes.
yeah. So uh, what I was saying, so the person who was getting error, uh, Vamshi, please send that video to me. I'll just sort it out. Okay.
Okay, ma'am.
So
Done, ma'am.
you guys have any doubt?
Ma'am, actually, you didn't share the videos, ma'am, yesterday's, past 2 days.
Check with Rakesh, sir. I don't know whether you guys posted it in group or not, but I've shared that link with him.
Okay, okay, ma'am.
Yeah, I shared the video links with Rakesh, sir. Maybe he will post it today or tomorrow. I don't know actually, but I
Okay,
have
ma'am.
shared it.
I will,
Yeah,
I will ask Rakesh sir and I will share it in the group, ma'am.
yeah. So I've already shared it with him.
Yes, ma'am.
So you guys have any doubt? Or you can,
Ma'am, ma'am,
yeah, yes, yes.
ma'am, we are unable to follow you, ma'am. Can you say it in a slow, ma'am? One, I think it's so fast.
The last part,
Yes, ma'am.
uh, like the parametric shift part, core loss, like where we are changing the material, which part you want me to repeat?
Param-
For the level, you are not audible. Akash,
Parametric, ma'am. Last one. Last
like
one, ma'am.
core, core material part, right?
Yes, ma'am.
Okay, I'll just repeat it. This is my journal, right? Okay. So, I want to see we can use different materials for our core, right? So, I, I I don't want to change my core material every time and analyze the thing. So, what I can do is I will keep my core material as one of the variables and will sweep it to see like how different materials with different materials what losses I'm getting so that I can choose one of the material to make my core. You understand this part? Why we need material switch?
Yes, ma'am.
Okay. So now we will see how we can do it. Okay. So s- first thing, where you are getting your variables, just click on Maxwell to the design. There you will this screen sorry, this window is there, right? Properties window. If you are not being able to see this window, go to view and property manager. Click on properties, project manager. Click on properties. You will be able to see this window. Okay. So from this window, double click on any one of the variables. So this pop-up window will come. Okay. After that, what you will do is first I have to add the name of the materials that I want to sweep. So I'll add array here. I'll just name is material name because I want now I'm changing it because material array is already present. So I'm changing the material name. Okay. Then editing, keep all this thing as it is. Then from here, form a uh, table, right? So I want to change between three materials. So I'll add three rows. So by default, you will see that the serial number starts from zero. So index number, what it is called, but I'm saying serial number just for understanding. So you will see that it starts from 0, 1, and 2. So uh, first material, I'll write ferrite. See, one thing is we can only change between material that is available in the list. Okay. So if you want to like if you want to change it to your own material, first you have to add that material in the list. A material adding and all we will cover, but not in this class. We will cover it tomorrow. Okay. So
Okay, ma'am.
I know that ferrite is available, right? Then iron is available. Then steel is available. You can see the list. Okay. You know how to assign the material. Their list comes, right? So from that list, you
Yes, ma'am.
choose your material like that. So these are the readily available materials in Ansys, but you can add your own material that I'm telling you 100 times, okay? And that we will do, but not today. So whenever you are adding the material, just add it in double inverted commas or else it will not work. Fine. So to form an array,
Yes,
you have to add your materials in double inverted commas. So you added your three materials, or you can add more if you want. I'm just adding three for you. Then I'll click on OK. Now I got the list of my material, but I want to make it as one of the variable, like extra variable I have to add for sweeping that material. So what I will do after making this list, I'll add one more parameter. So first what we did, we add array to add the name of our material. Then just click on this add. Okay. Then material, you can name it anything. Here name material number, then change it to array indexed variable. This is to this is the variable for your index number. I told you, right, that every material is having certain index number. This is the variable for that index number. Understand? Now here
Yes, ma'am.
uh, in associate variable 2 will come. I told you if you have multiple arrays, multiple will come. We will select whatever we want. So both are same. We can select anything, but I'm selecting material name because we just created it. So associate variable name is material name. Associated variable is the list that we made. Okay. So with respect to which list we want to associate this variable, we have to add it here. Then click on OK. Fine. Just add what, whatever you want to add here, then array whatever name you want to give, array index variable, associate it with the array that you with the list that you have made, right? And then just click on OK. Till this you don't have the Akash. You understand it now till this? Is it clear?
Yes, ma'am.
Yeah.
Yes, ma'am.
So uh, we are done with this. Now, how we can sweep it? Okay. Now we got the list of the materials and a variable associated with it. Now, for changing your material, you want to change core material, which is this, right? This is your code. So double click on your on that part and here write first the list name, which is like material name we have kept now, and then in bracket what is the variable that is associated with the index number. So I think we have named it as material number, right? And then click on OK. Understood? So if you want to change copper, then you have to do it for every binding. But because I'm changing it for core and there is only one core, yes, only one part of the core, so that's why I'm doing it for just one this thing, like for rectangular one. Okay. But if you want to change material of copper, then you have to do it for everything that comes under it. Okay. Then, such you understand this, or you still have doubt?
Yes, ma'am.
Yeah. Okay.
No, ma'am. Clear.
Yeah. So now, how we can change, like change the material. So what we will do is, we will go to we will go to optometrics, add parametric, then add what is the name of our variable material number, right? And then select linear step because we want uh, linear variation, right? So that's why select linear step. So it is getting start. Our index number was getting started by 0, right? That I told you in our list for our first material, index number was 0, right? Hello?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Then it was stopping at 0, 1, 2. It was stopping at 2, right?
Yes.
And step size was 1 because the first index number was 0, second was 1, and third was 2. So we will start at 0, end at 2, and step size is 1. So we will just add it and we will click OK. You can see from table. So this is your index number. So first material corresponding to index number 0 will come. then material corresponding to index number 1 will come, then material corresponding to index number 2 will come. Okay. And then just click on OK. Then you can just validate it and analyze it. Okay. So I told you that code loss and all we will be covering tomorrow. So today, like even if I run it, you'll not be able to see the difference. So tomorrow also, like this part, maybe I'll repeat, and then we can see the core loss corresponding to different materials, and like but we will not be able to see this now. And also we will learn how to add a new material to our list, like to our readily available materials, how we can add a new material. Okay.
Okay, ma'am.
Okay, ma'am.
Yeah. Tomorrow we will be doing, till now we were doing eddy current analysis, right? Tomorrow we will do transient analysis. Okay, so don't skip tomorrow's class. You will enjoy it. Okay,
Okay, ma'am.
Okay.
Akash, now it is clear.
Ma'am.
Thank you. So should we stop here?
Okay,
Yes.
ma'am.
Thank you.
Thank you for the session, ma'am.
Thank you.